अपडेट कर दीजिएगा सर।
ठीक है, मैं करता हूँ उसको। हाँ अनिल,
क्या प्रयास?
हाँ अनिल, you can start the meeting now. I'm making you host.
Okay.
हाँ हाँ, अरे गलती से लग गया। Yes Anil, now you are good to go.
Okay. Hello everyone. Good evening. Today on behalf of PGANC, we are conducting sessions on MATLAB. As we all know, MATLAB is very important in our thesis and coursework, and it will be very much informative and interesting to learn from the experts. So we are conducting the sessions every day. So please join and learn. In today's session, we have Keyur Panchal as a mentor. He has done his work in Siemens Energy, and he has a 4-year experience in teaching, and he has a experience in MATLAB for 1.5 years. So I want Keyur to please start the session and make it good. So Keyur, please start. And
Yeah.
I think you are host now. You can share the.
Okay. I'm audible?
Yeah, you are.
Okay. So thank you for giving me this opportunity. Good evening, everyone. So let's start. I want everyone to register on this website, matlab.matlab, giving in chat box, so that you can access MATLAB along with when we are practicing it. Okay. Use IITK email ID so that it will be easily. You don't need any license. It will be automatically activated. Okay. So let me share my screen. So any one of you, what is MATLAB? Any full form or any guess? What is MATLAB?
Matrix lab.
Matrix lab. Okay, that's correct. From the wording, it looks like that maths lab, but no, MATLAB stands for matrix lab. Behind the MATLABs, all the work is going through the matrix calculations, right? There are lots of matrix, and we are always working with the matrix anyhow, right? It was wrote by the Cleve Mollier in 1970, and then in 1984, few other people joined and they established MathWorks in US. And from that, it was gained so much popularity. Although you can see a lots of textbook with like that in the beginning, like solid mechanics with solve examples in the MATLABs or similar thing. Like many of the popular books have the solved examples in the MATLAB, and also in our coursework and thesis we are using a MATLAB a lot. Right? So before going into much detail, let's start. So I will go to the MATLAB. Okay. So let me give you the, when you go to the matlab.mathworks.com and log in with the institute email ID, this will open up, right? And here I would like to prefer using the MATLAB online because it is easy and you don't need to download and install anything. You can work directly with your browser and internet. So it's easy, and I request all of you to start using this only. So main thing we are concerning about right now is this command window and workspace. So in the command window, we are writing our command and we are getting our output there only, right? And in the workspace, what are the variables that are saved, we can see here in our workspace. Okay, so first we are starting with doing basic mathematical calculation, like similarly we are using our calculator. Let's say 2 plus 3, and when you write 2 plus 3 and press enter, it will give you an answer 5. It's super easy. You don't need any syntax, or you don't need to learn any much things. Very easy and very user friendly, right? Let's say 2 multiplied by 3 and press enter, it will give you answer. So you can see you don't need to define anything like another language, or you need to write a long syntax, right? So there is nothing such things. You just directly write things like 2 raised to 3, and when you press enter, it will give answer 8, right? Let's say 6 divided by 2 and press enter, it will give answer 3. I request all of you to do this along with me, so that you can also learn, right? This is the similar basic calculator which you are using, and it can also perform the task what scientific calculator would do, like sine of 30. And remember, this sine of 30 is in radians, and you need to make input in the brackets, right? Like it will give you answer, but it is in radians. If you don't put the
Hello,
brackets,
hello, sir.
yes.
Sir, I am using, join this meeting through my mobile, but when I go to join this meeting on my laptop, it is saying that this meeting is at capacity. It is reaches at capacity, so no participant can join further.
See, this meeting can hold only 100 people. So if you
Yes, yes.
want to join, you can. If you want to join with another account, you can use our YouTube link.
Oh, okay, sir. Okay.
So let's begin. If you don't put a bracket here, so it will give you an error. Let's try. So when you write sine 30, it won't recognize it, right? Sine is an inbuilt function of the MATLAB. So you need, if you want to give any input, then you need to place it in a bracket like sine 20. Press enter, it will give you an answer. But this is in radians, right? And we like working with the degree. So for a degree, we need to write a d before the brackets, like sine d and then 30. Okay. This way, if you want your in degrees, then you need to write a d like this, sine d 30. And when you press enter, it will give you answer 0.5. Similarly, let's say 10 d 30. It will give you an answer like this, right? For cosec, you don't need to write the whole cosec, you just write C as C, D 30, okay? And it will give you answer like this, right? So this is the way. And if you want, similarly, if you want cosec in the radians, then what will you do? You just write CSC 30. It will give you a intake in radians like this, okay? So in the trigonometry, we have seen the basic calculations like addition, subtraction, multiplication, raised to power, divisions. And trigonometry, we have sine, tan, cosec, and in the radians and in degree. And if you want inverse trigonometry, right? So what you do is you write A, then sine, and then do the bracket and give you input. Okay, sine values from, we know that sine functions value varies from -1 to 1. So if you want to place 30 here, it will give you, okay, let me check it, 0.5. Okay, sorry, it is in a still in a radian, so we need to make it in a degree and then write 0.5, right? Okay. So here you will get the answer 30 degrees. Here also, if you want it in radians, then you just don't write D, and if you want in degree, you write degree, okay? 10 to A inverse of 10 to. Okay, similarly for cos inverse, A cos D three. Write anything this way it is, right? So we have seen the basic mathematical calculations in the MATLAB. First we have did the scalar operations of plus minus multiplication raised to power thing. Then exponential and log functions we will see, and there are the trigonometric functions like sine, cosine, tan, cosec, sec. This is the by default it is in the radians, and if you want this in degree then you need to write d here, and if you want inverse then you need to place a before the functions. For log, let's say log. Also note one thing, when I write log, it gives me lots of hints. Okay. It is giving me the hint, so I can also check here. I don't need to learn anything. Right? It will give you the hint, so you can check log, log2, logical, anything. So I want natural log, but also note here it is an built-in function, so you need to put the value inside the brackets. Let's say I'm writing log 3 and pressing enter, it will give you an output. What if I want a log of another base, right? It's shown here. If you want a log for any another base, like let's say it was log 9 of x, the example given here. So what you do is you just write a log of whatever value you want divided by log 9 using the basic or mathematical formulas to find the base of any numbers of any log. Let's say I want a log 5 of base 3. So what I will do is log 5 divided by log 3. So I will press enter and it is the log 5 base 3. So you need to like write this way. It will give you the log 5 base 3. Let's say log 10 base 2. So for that you need to write log 10 base 2. And let me remind you one more time, for any function you write it will give you a hint, like if I write the sine, there are the numerous functions related to sine, so it will give you the available functions, inbuilt functions, so that you can choose from it. Also, this all are the inbuilt functions which are popular and which are used in day-to-day life. If you want to define your own function, then also you can define your own function according to a requirement, which we'll be covering in the next session, how to define your own functions. Okay. Similarly, you can do the exponential logarithm, right? So I would like to note you some point. So when you are starting loops, maybe you get into some infinite loops and MATLAB will hangs, right? When it started doing infinite loop, then you must remember the shortcut. When you press Ctrl plus C, it stops all the calculations, right? So remember this. And you see here we have we have written lots of command and it was failed. So if you want to clear this command window, you need to press CLC, and Workspace you need to use the clear. We will use these functions right, and adding semicolon will suppress the output. Okay. So here you need to note that the variables are stored here in the answer. Let's say 4 multiplied by 2. And then the answer is well for 8, right? So all this variable is stored, all the answers as an answer right here. So clearing this workspace and command window, use CLC and clear. It will clear that workspace and command window, right? So there are the 3 points. There, the control C is used to stop the MATLAB, CLC is used to clear the command window, and to clear workspace, we will use the clear. And let's give example to semicolon. Now here, when I write 2 into 3, it gives me answer 6, right? But what if I do 2 multiplied by 3 and add a semicolon at the end of the line? Okay, let's see what's happened. When I press enter, it won't do anything, right? It's not like that. It is doing its calculation, but it was not showing the result like this in above. Let's say 2 multiplied by 4, and it is showing me the answer. And if I add the semicolon, it won't show me the answer. So it will save your space and looks good. So add semicolon if you don't want to display the calculations. Now, this is the normal calculator that we have seen, but also we would like to work with the variables, right? So how we can play with the variables in the MATLAB. So there are sort of not much rules. There are only just 2 rules. The variable name should be start with a letter, right? It should not start with any numbers or any special characters. It will only start with the letter, right? And after that, it can be followed by letter, digits, and only underscore. Only the one special character allowed is underscore, right? So letter, digit, or underscores, and they are case sensitive. So let's work with the variable. Let's say a is equal to 2, b is equal to 4, and when I write a plus b, it will give you an output is 6. So it's easy, you don't need to any syntax, nothing. You just write a is equal to 2, b is equal to 4, and then a plus b will give you answer 6, right? So here what I will do now is to let a is equal to 5, and then I suppress the output because I don't want messy here. So it will define a is equal to 5, b is equal to 6, adding semicolon, right? So you can see here we have defined 2 variables, variable a, variable b, and its size is 1 cross 1. We will discuss size later. So all the variables which you have stored are shown here, and the latest, let's say a plus b, we have not defined anything about a plus b, so the latest answer will be stored here in the answer value. Okay, a plus b. So this is how you define the variable. You just write the equal to sign. Let's say a divided by b. We are defining this variable into c. Okay, so what is the value will be, you will get this output at c. So also I would like to give you the example of equal sign, right? When you write a equal to 5, it does not actually meaning like a equal to 5. No, it means there is the 5 value is defined in the a, right? This 5 values is going into the a. This equal to sign means. And if you want the real equal to that you are using in your pen and paper, then you need to write a double times equal to. Okay. When you are comparing something, so you need to write double times equal to. So let's here check here. A is equal to 5, b is equal to 6. And every time when you change the value, it will take the latest value and modify it. Now the a and b are modified, but I haven't do anything with the c and the answer, so it will remain as it is. So anytime, let's say a is equal to, I will do a plus 1. So now my a is modified, right? A is no more equal to 5. If I want to check what is my a, then what will I do? I will just write the simply a and press enter. So my a is become, it is not equal to, right? Okay, you know that a does not equal to a plus 1. We know that this is the impossible. It is only possible for a equal to no, sorry, it's not possible anytime a is equal to a plus 1. So here the equal to sum does not mean actually equal to. It was assigning the values from RHS to LHS. So now my a, as you can see, before my a is 5, but now my a is 6. So how many times to define the variables it will take the value. Let's say I will define my value a is equal to 0, and let's check what is it has changed or not. And I press a, enter, and it is giving me the value 0, right? So how many times you modify your variable, it will change your value. And variables are quite useful. We will do one problem here with variables, right? So we all have learned physics and maths in the 11th and 12th, right? So this is the quite easy problem I have selected just to demonstrate the using of variable. So let's see. A car is currently traveling at 15 meters per second, and I want answer from you guys, right? A car is currently traveling at 15 meters per second and is accelerating with a constant acceleration of 5 meters per second. So you can say your velocity is 15 meters per second, acceleration is 5, and time is equal to 5 seconds. Okay, so I will define the variable like this. V is equal to 15, press enter. Okay, I request you to solve this on your own. Can anyone solve this using MATLAB? Please don't use your calculator. Solve it using MATLAB. It's easy. I can see there are lots of answers. Okay, so let us solve now. I am defining velocity as 15. Sorry, I was defining initial velocity as 15. Okay, acceleration is 5, and you don't need, if you want to take a space between before and after the equal, and if you don't take, then also it will be fine. Like let's say time is equal to 5. I am not taking any space here. It will fine. It will work, right? So I have defined my 3 variables. Let me first clear the screen, clearing the variables, and solve this question. Okay, you see now it's a clean workspace and a clean command window. So let's begin. My velocity is 15. So I'm defining initial velocity as 15, v0. Okay, then acceleration is equal to 5, and time also equal to 5. So final velocity was asked. So we will write the v. We know the formulas. V is equal to v naught plus at. But if I write it like that at, then it will return an error. Let's say I am pressing enter, and it will showing me the error. Why? Because at is not defined in the MATLAB, right? I have defined a variable a, t, and v naught, but MATLAB don't know what is at. So we need to write v is equal to v naught plus a multiplied by t, and you will get your answer, right? V. And similar thing, if you write, let's say I'm writing similar thing, I can suppress my output using semicolon. So it will not give any output. It will calculate, but don't give any output, right? It will be, using variables will be helpful. Here it was not editable. Like if I want to type, it was not editable, but in script, you can edit the variables and do a lots of complex calculation just by changing the values in your calculator. It's hard if you are using 10 to 15 equations and manipulating it, then it will be super easy to do this. Okay, let's move further. So answer is 40. uh, Anyone have any doubt till here? I can't see anything in the chat box. So it's easy now, and we are learning from scratch. So don't worry, it will be easy and practice every day. So one day you will become the master of the MATLAB. So now diving into the heart of the MATLAB, that is the matrices, right? So as you all know the matrix, but then also let me remind you the basics of a matrix. The horizontal lines are known as rows. These horizontal lines are known as rows, and it is given as the row 1, row 2, row 3, and vertical lines are known as column. It's column 1, column 2, and this is called the element of a matrix. This you already know, just to remind you. And the dimension of the matrix can be written as 3 into 2, like row into column. How many rows are there? There are 3 rows. So I'm writing 3, and in the column we have 2 columns. So I am writing it as an 2. Okay. So dimensions, please remember, don't confuse between this dimension. We are using row into column, right? First value will shows row, second value is column. This is the 2-dimensional matrix. Anyone knows about the 3-dimensional matrix? Yes, anyone? Okay.
Cube.
What?
It might be a cube.
Yes, it's in cube, right? You are right. It's in cube, but how will you write the values in it? In 3-dimensional matrix, let assume that you are writing this matrix, this 3 by 2 matrix on a sheet of a paper, right? Then turn the page, you are writing some another 3 by 2 matrix. Remember, the dimension should remain same. You are writing another 3 by 2 matrix on the second page. Then you are writing another 3 by 2 matrix on the third page. And when you pile up this matrix, this kind, it will become the 3-dimensional matrix. And as we have used the 3 page, then it will become 3 by 2 by 3. Okay. Everyone understood? Moving further, we will mostly use the 2-dimensional matrix, and we will see some 3-dimensional matrix also. So we will see how we will define the matrix. Okay, let us clear this thing, solve things, CLC, clear. Okay, now let's say I will define matrix A is equal to 1. We will define this matrix only, 6, 10, 5, 3, 0, 2. So note how I am writing here, 6, 10. This is my first row is over. After my between the two elements, you need to apply space, or you can apply the comma. I will give example of both of the things. So in the first column, we have 6 and 10, right? We can see here, you have 6 and 10 in the first row, and you have 6 and 10. In the second row, we have 5 and 3. So in the second row, we have 5 and 3. Remember, here before 5 you can add space, or you can't. If you don't add the space, that will also be okay. So we have defined our first row, we have defined our second row, and for third row we need to place this. And what is our third row? 0 and 2. So 0 space 2. And when I press enter, if I add semicolon, it won't give me any output, but check, A is stored here in the variable. And if I type A and press enter, it will give us like this. Okay, we got the similar matrix here. We can also write it in another way. A is equal to brackets 6 comma 10 then semicolon 5 comma 3 semicolon 0 comma 2. Right, it will give you the same result. So you can use comma or space according to your convenience. It both will be fine. And let's say I am defining variable a is equal to 1 2 3. I'm defining a square matrix 3 by 3 4 5 6 7 9. So here you can see the space gives you the different elements and the semicolons goes to the next column. Here you can see we have two variables, capital A and small a, which we have discussed in the rules of the variable, that the names of the variable are case sensitive. So capital A and small a both are treated as the different. They are not the same because they are case sensitive, right? Okay. So moving forward, let's say there is no element in one of my element. Let's say there is a in row into column. Is there anything in the chat? Okay. Let's say here in the first row, third column, we have element 3, right? I don't want that 3. There is an empty space. For empty space, we are using a capital NaN. Let me show you. If there is any empty space, what you do is, okay, this is our matrix A. This is the 2 times. Here, if you want an empty space, what you do is NaN. Write this. Okay. Press enter. It will show the NaN, right? NaN stands for not a number. Okay, so first we have done with the scalars with only one quantity, right? And then now we will deal with the vectors. Vectors are one dimension. Either you have one column or one row. You have vectors in 2D or 3D, or in the higher dimensions also possible. For let's say factor V is equal to, here I am making a column matrix 1 1 2 3 4 5. Enter. It gives me a column matrix, and writing the similar way is equal to, in the row matrix you will get 3 4 and 5. This is that the row matrix. Okay, now let's say if I want the matrix up to 1 to 100, then it will be hard to write all these things 1 2 3 4 5 up to 100. It will take a time and it's quite boring. So there is a very interesting function, built-in function in the MATLAB. What I do is, let's say I want 1 to 10. See, if I want 1 to 10, but I don't want to write, then what I will do is I will write like this and press enter. It will give you output like 1 2 3 up to 10. You can write it anything. V is equal to, you can, first point is the starting and second is the ending point, and the space between two elements is 1. Okay, so let's say I want to write 5 to 15. Note, don't confuse in this space. It just give good looks. You can keep space or remove it. It doesn't matter. Pressing enter, it gives me this, right? So it starts from 5 and ends with 15. One more example. You can start with 100 and ending into 105 and press enter. It will give you 100 up to 105. Okay, but still, let's say there is the difference of 1 unit between any two adjacent element, right? Here you can say 1 and 2 3, 1 difference, 5 and 6 and 5, 1 unit difference. So here the starting point and ending point is defined, but it was taking only one step at a time. But let's say I want a step of 2, 3 or 0.5, anything. So what will I do in that case? Let's say I want a step of 2, right? What I will write is 10. Okay. So I get 1 plus 2. 1 plus 2, that is 3. 3 plus 2, that is 5. 5 plus 2 is 7. 7 plus 2 is 9. So here our step is 2. So you can change your step also. Start point, end point, and the middle thing is the step. Let's say factor v is equal to 1, 0.5 and 10, and pressing enter. Yeah, here you are getting your steps as 0.5, 2, 2.53 up to 10. So you can change your step like that. Also, okay. So this is how semicolon is used. It used to creating a range of variables. Let's say in 2D. Right. So let me create this letter. I'm defining one variable, sorry, matrix E. 1, 2, 6, 9. So pressing it will give you this matrix. Let's say I want to know it is not here, and I want to use, or I want to know what is the element at the second row and third column. Second row and third column. Here we can see the element is 6, but I want to do it automatically. I want to check which is element is there in the E matrix at second row and third column. So it was also giving suggestion. What I will do is I will write 1A, then bracket, then row and column. So I want second row and third column. I will write like this. Just in which matrix you want your variable of matrix A at second row. So remember, first numbers denotes the row, second number denotes the column. So second row, third column, pressing enter, it will give you answer 6. It will give answer 6. So this way you can check because here there is a 3 by 3 matrix and only one matrix, so you can see directly. But many a times when you have lots of matrix and their size are also a bigger one, at that time it is useful. Also, if you want to use it in some calculation, when you automate the work, then you need this function, which you will learn in further sessions. Here, let's say if I want to change this value, here it is 6, but I want to change this value, then what I will do is simple. It's very simple. Just I will write 2 comma 3, then equal to, let's say I'm modifying it value to 0, and so pressing its output, pressing enter. Okay, it's completed without any error, and let's check it is modified or not. Pressing enter. Hence you can see the value is modified. Before it is 6, now it is 0. So that is the one question. Using small bracket and large bracket creates a problem. Yes, it will create. So brackets are defined very well. So you need to use only that brackets which are there. Okay. So yes. So we have seen how to retrieve the information of any element in the matrix and how you can modify it. Okay. Moving further. And we can see our work is not editable, right? We can't edit. Let me show you here. You can't edit this function. Once you have pressed enter, you can't edit, right? You can't edit these things. You can see if you write anything, you can't edit anywhere here. Okay. And it also creates a lot of clutter, non-editable, not look good. So let's make our work easy, editable, clean, editable, and liftable. So let's learn one more feature before learning more about matrix, we will use a script. And there are two types. One is the normal script and one is the live script. We will demonstrate the use of both the things. We will start using the script and then we will use the live script. So one more thing, the same percentage the command line. Okay. So for start using script, you can see this button new script here, right? Just click on it. It will open a script like this. Okay, this is like your notepad, similar to your notepad. You can write anything and you can delete. It's easy. So whatever you write here, let's say I'm writing CLC and clear, so that workspace and command window will be clear. So before I need to save this, I will there is no space allowed in its name. Script _1, enter. So this is my first script I have written. This is the CLC and clear. It clears the command window and workspace, but you can note it's not cleared right now. So what I will do is you need to write run. When I press run, it will clear. It will go through all these lines, and first line it will go through CLC and clear, so it will clear the workspace in command window. So in the starting of script, it is a good idea to write all this three output. Okay, it will clear all the plotting and all the windows, and it will clear your command window and workspace. So it is a good practice to write all these three things in the starting, and when you press a run, it will go through this code. So now you can see our code is editable, that I can edit at any time. And when I press run, it executes the command. Let's say I'm writing the matrix, and here one more thing also you need to note, that when I press only one square button, it will automatically create another square bracket and move my cursor in the middle. So it will be easy. I don't need to worry about other things. I'm creating this matrix 7, 8, 9, and you need to save it. I have saved my script, and then I press run. It will you can see your output is here in the command window. Here your variable is stored in the workspace, and here is the command window. So in the chat box, Coel, yes, you can create, but any sequence you wish to do, but not direct functions are used. One more sequence I'm covering, and you can create any sequences using loops, but not direct given. There are direct, only two functions are given, and one is I have discussed, and second I'm going to discuss. And the location of the file is on the MATLAB drive. It's stored in the online, and let me show you. You can write drive.matlab.com. When you go through this drive.matlab.com, I get to log into it. You see, I have created a script one. It is here. So all the files are saved online only, and you can access your files. You can download, make folders of your files, and manage all your content here. Also, you can see your files here also. This is the script one, right? And you can also create a folder from here, and you can delete or copy your files, rename anything. All the file manager options are here, and the files are saved in the cloud. Okay, so here you can see we have written matrix A and it was given in the output. And if I write put here, and let's say I'm not writing CLC clear close all, then what happens? Okay, let me save it first. Then when I run it, the above thing was not removed. You see, the script one is started from here. So it's a good practice to write CLC and clear and close all at the starting. And save. So for saving your file, you can use Ctrl S or click here. To run your program, you can use F5 or just click here, and it will be fine. Whatever you like, you should do. And as we have used the semicolon here, A is not shown. If I remove the semicolon, A will be shown, right? So now onwards, we will working with the scripts, and I will give you demonstrate of the live script afterwards. So script will be easy. It is editable. It looks good and easy to work with. When you have long programs, you should use script. Don't write directly your programs in the command window. Okay. So coming back to our matrices, let's see, there is one more sequence creating tool, that is the Linspace. Okay. So let us see how it works. So let it be. Let's start. So I'm defining my vector is equal to 5, 10, 11. Comma 11. And when you are writing, you will MATLAB will also suggest about it what you are writing. So let me give the one easy example before going into it. 5, 10, 11, and saving this file, and then let's run what it gives you output. So you see, your starting point is 5, your ending point is 2, and the number of elements is 11. Let us uh, let us say when you need a number of element 3, saving the file, run. So it's easily readable. Okay. So your starting point is 5, ending point is 2, and total number of elements is 3. So 5, 3, and 2 that are equally spaced. Okay. Here you define the number of elements you need, and in the previous, without Linspace, you can write semicolon. These are the two types where you can use. Let's see what let's give you output. And as I am not defining any variable, this value will be stored in the answer variable that will be automatically defined by MATLAB. If I am not defining, then MATLAB will define. Okay, it is showing empty double row vector. So there is nothing. Let me increase my size. Why it was written here? Because 5 plus 2 will be 7, but my limit is 3. So it results into an error. So writing, let's say 9. And then, okay, so 5 plus 2 is equal to 7. 7 plus 2 is equal to 9. So this column operator work like this. Whereas the Linspace, you are giving a starting limit, ending limit, and number of elements. Okay, and in the this column, you are it's like arithmetic progression which we have learned. When the first element, it was adding 2, then 2, and up to 9. Let's say here it is 9. Let's say here it is 10, which is not in the EP, right? 5 plus 2 will be 7, 7 plus 2 will be 9, and 9 plus 2 will be 11, which will be outside of our limit. Let's see what's happened. So it won't go beyond its limit. We have defined its starting point, ending point, and the number of steps. And here you are defining step size in column. We And in Linspace, we are defining number of elements. Okay. And what you see, the color changed. Why? I have write the percentage before the starting of the line. It means it is the comment, right? If you want to comment in the MATLAB, you just write the percentage in the starting so that it will ignore. Why we are writing comment? Just for our understanding, nothing else. When you have a long program, for your understanding, we are writing a comment for what the function we are defining or any other thing we are writing comment. When MATLAB sees the star, it will just ignore and move further. Let's see what happens. There is no change. You see, I have write these two lines, but there is no change. Okay, decreasing sequence. So decreasing sequence, you know the difference is -1. Okay, there are another question. How 2.5 come, 3.5 come. Okay. Mhm. So you see, I have defined the upper bound, lower bound, and total number of elements. So it will adjust by itself. Okay. Then by uniformly distribution, it will give you the here three elements. If I write, let's say, 5 elements, if I want 5 elements, saving it and running it. So it will automatically uniformly distribute and anyhow give you 5 elements. See, if possible, right? 3, 4, 5. We got 5 elements. Let's say my upper bound is 5 and starting with 15, and my element will be 3. Okay, saving it and run. So it gives my lower bound, upper bound, and number of elements using Linspace. Okay, you can probably take it screenshot. Yes. Number of elements. Okay. Next question. Can we go decreasing sequence? Yes. So in decreasing sequence, let's start with 10 and go to 1. Okay. So in that case, in arithmetic progression, we are writing the D, right? We are defining the difference between two elements. So if you go the reverse, then your difference is negative. So what you do is 10 semicolon -1 semicolon 1. Okay, saving this file and then run. It will go like this: 10 -1 9 -1 8. You can choose -2 or -2. Let's say -2.5. F5. 10, then 7.5, 5, 2.5. Yeah, and if you write 0, it will give you 0. Okay. So how did you name the right column as a command window? So I don't know what we are seeing. Please elaborate. Ram Tej. Okay. Moving further, we have seen this Linspace, which we are define upper bound, automating in Linspace or column, we are automating our vectors. Okay. So moving further, and now we will do the matrix algebra. What we have did with the scalars, like adding, subtracting, multiplication, and here some are the new terms, and we are finding the trace, transpose. Okay, so we will perform this with matrix, but remember, I will clearing all this matrix, and I will perform the algebra with matrix. Remember, these matrix operations are bound with some rules. Like you can't add the dissimilar matrix of different size. Let's say my matrix A is 3 by 3. So you can't add B matrix of 2 by 2. Let's say my matrix is 2, 3, 4, 5. I'm making this matrix as 5, 6, 8, 9. Okay, so A is the square matrix 3 by 3. Let's see, and B is not. The size of A and B is different. Okay, so you can't perform all the operations like multiplication, addition. These things have certain rules in the matrix, so you need to follow that mathematical rules. If you go beyond that rules, then you will end up with error or some results which are wrong. Okay, so don't do that. Let's say A is 3 by 3 matrix, so I am defining two 3 by 3 matrix square matrix 9. Anything you can write. Okay, so saving the file, running. So now I have two 3 by 3 square matrix. So if I want to add, then I will add A plus B, saving this file and running. So you will get your answer as A plus B. You can also check 1 plus 2 is 3, 2 plus 3 is 5, and so on. So, and as we have not defined A plus B, it was stored in the variable answer, temporary variable automatically given by the MATLAB. And if you want to store into some another variable, let's say I'm storing it in C, okay, and you see now all my work is editable, and if you are writing directly in the command window, it will work, right? It will work, but it is not editable and not that much good. So we will use a script or live script. So let me save my file and run. So now my answer variable was gone because I used CLC and clear, and here C is defined as A plus B, right? Similar way you can use multiply, C, and then run. So it multiplies A by B. Also remember multiplication of matrix. Let's see, let me write it here. Let's say A of m comma n, B of P comma Q. From maths, we know that multiplication between A and B is possible, A multiplied by B, if n and equal to P, right? If n is not equal to P, then it will show, yes, you are right, n is equal to P. If n is not equal to P, then it will show you an error. So here, both the matrices are 3 by 3. A multiplied by B will work. Let's see. A multiplied by B will work. Now I am changing my B vector to 2 by 2. So now my B vector is 2 by 2, and it not follows this rule. So it will show you the error. Let's say. So it is written incorrect dimensions for matrix multiplication, right? So when you are using this matrix algebra, you need to take care that all the maths rules are to be followed. Otherwise, you will end up in some error. So going back to our 3 by 3 matrix, same this file. Okay. So, okay, addition, subtraction we have covered. We will now see the inverse, trace, and transpose. Okay. So, what is transpose? You know, anyone? What is transpose of the matrix? Do you know? So, anyone don't know what is transpose of matrix?
Rows becomes column.
Yes.
No, frozen column.
Yes, sure. So for transpose of any matrix, what is the transpose? The rows and columns are changed. Let's see. So here, if you want to take a transpose of A, what I will do is just write this. Okay, save this file and run. Here I have it was check, it was written as answer because I have not defined it. So A, previously my A was like this, and it was this rows are changed to column. You can check 4, 5, 6 rows, it becomes column 7, 8, 9. rows, it becomes column. Okay. So if you want a transpose, you just write it like this. If you want inverse, inverse means what? It just raise the power of -1. Yes, I will write it like this, nothing else. A inverse, and I will click run. Oh, there is some error. Let me check. Maybe matrix was singular. Changing the matrix A to the power, let's say -1. Okay, save and run. So you got your A inverse. This is your A and this is your A inverse in the answer. And we also know that A inverse is not possible for scalar matrix. So if you have some scalar matrix, then you will end up with the error. It's quite easy, no? Because calculating the A inverse of an 3x3 matrix will be take some time, 5 to 10 minutes, right? So it's easy in the MATLAB. A inverse, we have cleared A transpose, and here also, if you, let's say, if I want to multiply A multiplied by B transpose, then what I will do is A multiplied by B, and here I will put this. Okay, then I will save. Then what it will do is it will multiply A multiplied by B transpose. Okay. Roshan Kumar, where we define gap between first and last number, can we use variable defined in equation? Where we define gap. I don't understand your question, what you are asking. Okay, we will take question answers in the end. Right, so we have, okay, trace is left. So you know the trace of the matrix, trace is just the addition, and here note that trace is the inbuilt function, so you need to put the brackets. Whatever the entry you are giving, you need to put that entry in the brackets. Saving the files and click on the run. Okay, so trace is addition of the diagonal elements. Okay, let me delete all these things, not needed. Saving this file, run. So trace A, so you can see the addition of diagonal elements. 1 plus 5 plus 9 is 15, that is the 15 answer is given. So in the calculation, if you require the trace, then you can write A. Let's say if you want trace of A multiplied by B, or A is capital here, and if you want trace of A multiplied by B, then what you do is write A multiplied by B. Saving the file, running. Okay, there is some mistakes. Okay, if I write B by mistake smaller, then it was not defined, so it returns an error. So that B capital, saving the file. So you can see AB is the this, and addition of this diagonal elements is trace, and this will give us 286. Okay, so this is how you will get a trace. We are running out of time. I will take questions afterwards. Okay, I will try to answer all your questions in the end. And one more thing, let me show you one more thing. Let's see, I have a matrix A that is defined by the variable, let's say Linspace. You can also use the Linspace inside the matrix. Okay, I am writing 1, 2, let's say I need 5 elements. Here also I need to take 5 elements. Let's say 4, 7, 4. Send this file and run. Okay, so now my A is this. So you can see I have used the Linspace inside the matrix, but it should be like it should follow all the rules of matrix, right? Here also 5 elements, here also 5 elements. starting point 1, ending point 2, starting point 4 and 7. So here you can say starting point 4, ending point 7, number of elements are 5. You can use like that. Also you can use that column. Let's say one column, there are 5 elements, right? So I will write 4, 5. Okay, saving. And so here you get the third row with 1 2 5, 1 2 3 4 5. So you can use any combination of Linspace or this and column matrix. You can use a space, or if you don't want to use space, that will also be the fine. Right? It will fine, it won't change anything. Okay. Any more questions? Okay, if you want secondary diagonal, you can use a trick, transpose the matrix and get like if you want secondary diagonal. Oh no, sorry, it won't change. For secondary diagonal, direct not available. You need to use loops, and you can find it using that way. Okay. Now you can also multiply anything with matrix, scalar multiplication or division. Let's say if I type A and multiply 3, 3 will multiply with all the elements. This is also the rule of maths we have already learned in the school, right? That 3 multiplied by 1, that will be 3, 6, and if you divide, it will divide with all the elements. Let's check. Okay, here what I'm doing is, let me delete all this. If I want to multiply 2 with all the elements of A, then what I will do is A multiplied by 2. I will just write this, saving the script. Let's run. So what's happened? My A is this, and I multiply 2 with A. Then 2 is multiplied with all the elements. You can see here in the answer 1 multiplied by 2, 6 multiplied by 2, 3 multiplied by 2, 6. Similar. You can also divide it. Let's say divide A divided by 2. Okay. So with scalar, right, here I am performing the multiplication or division with the scalar quantities. And if you want to do it, let's say matrix with matrix, if I'm multiplying A multiplied by B, you know this multiplication, let me show you. We are multiplying A multiplied by B. So if we are multiplying, our general rule tells this taking first column of A, sorry, first row of A and first column of B and adding this, that will give you 59. Okay, this is how A multiplied by B works. But let's say I want element by element multiplication. Let's say 1 multiplied by 2, 6 multiplied by 3, 3 multiplied by 4, element by element. If I want any algebra element by element, then what I will do is A multiplied by B, but I will put a dot here. If there are two both are matrices. Okay, if there is a scalar, I'm writing A multiplied by 2, then 2 will be multiplied with all the elements, but I don't need to put a dot here. But if I want both are the matrices and element by element multiplication, then I need to just put a dot below. Then you can see here, okay, I need to suppress this output. Okay, so here we have, this is the output of A multiplied by A dot multiplied by B, right? Element by element multiplication. So 1 multiplied by 2 is 2, 6 multiplied by 3 is 18. You can see, and A multiplied by B is different. We know that also. A multiplied by B is different. This is the element by element multiplication. For any algebraic application you want, any sign, element by element, then you need to put a dot before that. Okay. Moving further, I already explained how you replace the individual elements. Okay, and most important thing, eigenvalue and eigenvector, how to find. We know when I was in school, it takes a lot of time. It's quite boring, right? To find the determinant and the eigenvalues, eigenvectors of the matrices, right? So all the basic calculation you can do it easily. Okay. Dheeraj, how to multiply a particular row? No, you can't. There is no direct function for this because they are giving direct inbuilt functions for the basic all the things. These things you can do easily by using loops, right? When you start using loops, you can automate all your work the way you want. It will do thousands of times, any number of times you want to do, right? Once you start using loop. But these are the basic functions that are used day to day. Okay. Hmm. I will get back to you, Ramtej. Just wait. We will cover that also. Uh, so what I'm asking is, okay. So we are going that eigenvector, determinant, and eigenvalues. So let's say I want. Okay, forget this. Let's say if I don't want this vector b, then I simply comment it, so it won't be now you read by MATLAB will just ignore this. Okay, so you can comment any line if you don't want that. So let's say I want the eigenvalue of a. When we are finding eigenvalues, you just write eigen a, that's it, finish, saving the file, then run. So this is the eigenvalues of A, and you see we have the complex eigenvalue for A. So it's quite easy, right? When you are calculating on paper, it will take a lot of time. Right, to find eigenvalues of A. And let's say we want to find the eigenvalue and eigenvector, then what we will do, we will write like this: Vd and eigen of A. So I will write it V comma D, eigen of A, saving the script, and then run. Okay, so you can see, let me change the values if we get some good figure without complex. No, we are getting complex only. Okay, leave it. Here, if I want eigenvalue and eigenvector, then I will simply define two more matrices V and D, and write it at eigen A. So you can see here for V you get eigenvector, and for corresponding eigenvalues this. D is in diagonal matrix, all other entries are 0. There is only entries in the diagonal, right? You can see the diagonal entries and V. So for first this, you can see here for this eigenvalue, you have corresponding this eigenvector. For this eigenvalue, you have corresponding this eigenvector. So V and D are having V for vector and D for diagonal. To get that eigenvalue in that, you can define any variable here. Let's say B or C, saving and run. So that value will be stored in that thing, right? C and B. But C, what C will give you the first here, whatever you define. First thing will give you the vector, and second matrix is whatever you define. You can write your name also, nothing. Okay, so whatever you define, it will give you the eigenvalues. Let's say I can also define my name. Let's say Q. So it's easy. Whatever you want, you can write. And we have seen the variable names. You can write MATLAB 1. It will take, right? But if you take one MATLAB, will it work? Anyone? Do you know? Will it take one MATLAB? I have written the variable name is one MATLAB.
No, it won't.
Starting cannot be a number.
Yeah. Yes. So very good. You remember. So when I click the run, it will show some error, right? Because the variable name can't be start with 1. So let's move forward. So now on, you can find your eigenvalues and eigenvectors. You can verify using MATLAB easily. Just go to matlab.mathworks.com Our institute have license and it's easy to calculate. Moving further, if you want that square of all the elements individually, so you can write this also. Okay, dot, right? So one student had asked, some of you have asked some question regarding this, and so here it is, inbuilt matrices. So we know we have one identity matrix. We know it has only the diagonal matrix 1 1 1, nothing else. So there are some inbuilt matrices are present in the MATLAB, right? So you can create matrices of zeros, right? All the zeros, nothing else. Delete it. Let's say I will also commenting it for further use. So there is nothing, right? If I run this, there is nothing. A and B are commands, so MATLAB will just simply ignore that. So now I'm defining A as zeros, not zeros. It's zeros. So 2 comma 3. Let's say I'm saving my file and run. So what it happens, it will create a matrix of size 2 comma 3, where 2 stands for rows, 3 stands for column, and all the elements are 0, right? Understand? Similarly, you can also do for ones. So if you write ones, so what do you say? It can be for twos or threes or not? Minus ones.
No.
No or yes, why not? You can write, your voice is cracking. You can write in the chat box. So twos function or threes function is not available. Only zeros and ones are there. Because if MATLAB will started giving all the function, then it will be goes to infinite 1, 2, 3, 4, and so on. Let's say threes, right? Okay, run. It will show you the error because there is no such function by default defined, right? But you can always also define your own function. We will see in the further session how you can define your own function and use that. Yes, so this is our ones. So ones 2 cross 2 by 3, 2 row in the column. You can say 5 by 7 and run. It will give you this. Okay. So you remember I have told in the starting about the 3-dimensional matrices, right? So how you define the 3-dimensional matrices? Here I just need to write a 3. Here, okay. Also I need to I forgot to give you this definition of size. Here you can see A is defined 5 by 7. Okay. Size is 5 by 7. Here it is 5 by 7. And now I am going into higher dimensions, third dimensions. Okay. Okay, so here we are going to higher dimensions. Yeah, someone has told Ramtej, yes, you can always multiply and get whatever you want. Yeah, you can use, once you get used to it, you can use your own idea and get things. So here I am defining that 3-dimensional matrix. You see, then on the first page, here it is once. On here, the second page, it is also once. In the third page, it is also once, right? And let's say if I want to change this element, this last element, then what I will do is I will suppress this output. I'm modifying the value that we have learned earlier, how to modify this value. Is equal to, I'm modifying that value will be by 0, okay? And then I will see how my A will look like. Okay. There is some error. It was modified here, sorry. It will be like 5, 7. Okay. Here it was modified. So see, this is the 3-dimensional matrix. This is your first page. This is your second page. This is the third page. You can go on higher dimension, lower dimension. This is like this, okay? So let's create the identity matrix. we will mostly use work with 2 dimensions for creating identity matrix. Do you remember what is identity matrix? Only diagonal elements all are 1 and rest all the elements are 0. So for these are the automated by default matrix, okay, by the MATLAB. So you can write all 3 4 by 4 also, you can go, right? And as much as you practice, okay, page I am talking, it's not page. I will explain that later in the last ask me. Okay, so this is the identity matrix. If you write 4 by 4, you will get the identity matrix. Let's say you're writing. I need some random anything. I don't care. I just need any matrix. Okay, so I'm writing 3, 4 RAND and running this. Okay, so this will create any random vector. Note here, let's say I'm also commenting this. Select this. Select this. Right click. Comment. First time I got B and let's save my file. Let's run. You see, the first time I got B like this, and second time my B was different. Why? This is the A will be same, identity matrix will be same, but second time I have not cleared my screen, so first thing will remain as it is, and I will going to the second time. I'm running my code. I'm running my code third time, and you will get third time. This is my third output, and first 2 outputs are not deleted. So that's why we are writing CLC clear and close all. You will understand its importance afterwards as you start practicing more and more. So here, see, the matrix B at all the 3 times are different. This time it was different, this is different, and third time it was different. Why? Because it is anything, it is random. It will gives you any values. Okay, so this is the by default third. Okay, so and one last thing remaining is the diagonal matrix. Okay, so here what diagonal matrix will do, let's say I am defining A is equal to 1 semicolon 6, and we need this. You can select right click with the mouse and uncomment. It will be fast and easy. Saving the files, running it, so it will clear all the others, and it will return 1 to 6. 1 space step is 1 and starting and ending is 6. This is how 1 to 6 goes. Now let's say I need the diagonal element, diagonal matrix with all this element. Then I will write like this, saving it and run. So you can see my vector is changing to this matrix. So this is how this diagonal function is used. You can convert your vector into diagonal matrix. Moving further, concatenation. Okay, what this concatenation do is, let me reduce the size, 3 by 3, not 2 by 2. So here I got this 2 vector, and with the diagonal function I have created my vector. Okay, so concatenation, what we will do is we will changing A is equal to this way, capital A comma capital A. So what it will do is it will place A side by side. Let's run it. You see, oh sorry, we need to define A here. So my A is this. I need to suppress this output. My A is this, and what I have modified A by placing A side by side. Look here, I am placing A side by side, and it will give me output like this. You can place 3A unless you are, it follows the rules of dimension. it will work. I'm placing 3A. Okay, so it will place 3A. Also, you can do it column wise. Let me show you this column A and run. So you see, it will place one over another, right? One by one. So this is the concatenation of matrices. You can join the array. Okay. You can also change the format of the command window. Right here, I'm writing, let's say, format short. Saving it, you need to start in the beginning, otherwise it will work. So there are this short format give work for the decimal value. It will give you the 4 decimal value, right? If you want a format long, it will give you 15 decimal values. Format bank for 2 values, right? Format compact, loose, and we will see compact, loose, and this. Okay, so we will define this with the using of pi. I'm commenting this. We will don't use this. Okay, let's say I'm writing pi. For writing pi, you will just write pi. So our format is short, so it will give you only the 4 decimals. If I'm writing format long, saving it and run, it will give you the long, right? And there is also one more format which is popular bank. It will give you the 2 decimal. So whatever you are using, you can choose the format. And let's say you have lots of things here. I am uncommenting all the things. Okay, so let's run. So it there is lot of free space here, right? So if I write format compact, okay, so you see all the things are available on the single page. There is a less space is used. If I use a format loose, then it will, you see, you can find the more space. So there are also lots of another formats available. So you can explore when you are practicing MATLAB. So you can explore that. Okay. And if you write just format, then it will go to the default format. Okay. So whenever you stuck at anything, right? So you can refer to the documentation. So what you need to go is, you need to write this document of ones or help with ones. If you need help with any function, what you need to do is, you just write in the command window or that. Let's say I need a help with the sign function. So I will type a help sign and this, then just press enter. Okay. So here you can see the type of sign, documentation for sign, other functions, and if you click on this, it will open the help and you will see all the functions. This is official by MATLAB. You will see all the details, how you plot the sign, what is sign, everything is available in the documentation, right? So if you are confused about any of the function, also is the geometrically plotting, they have explained in all the possible way for all the function available, right? Let's say you want help with ones function, we have used ones, right? Just press enter, it will give you the documentation how you can use ones with arrays, right? This way you can access the help. Okay, so just to wait for some time. We are going to question and answer session soon. Okay, please wait some time. It's over now, almost over. So this is the basics, right? Very, very basic. How you are using MATLAB just as a calculator, right? But in the further session, you will learn how to use MATLAB for more use. How you can use more when you started using loop scripts and when you started using your own functions, right? Then you can automate all your calculation function very easily. And as you study further, you need more, like lots of calculation, right? And if you change any one or two, let's say formulas or any value, then you need to calculate all the things from the starting. But in MATLAB, what you do, you just change that thing in the script, run it once again, and you will get that change. Okay, so you can analyze all the things, and that is the easy. And for loops, you can, like, say all the boring work, it will do several number of times. If you imagine doing yourself, it will takes a lot of time, so it's very easy. Then you can plot your functions in probably in second or third session. The plotting is the very popular function of the MATLAB, right? With the plotting functions, you can analyze your things very easily and very effectively. It's plotting is very important. You can apply numerical methods, and those who know about the numerical methods, it's very tedious, it involves lots of steps, similar steps. You are iterating same thing, so you can easily do with the MATLAB. It will do it for you. You can solve ordinary differential equation, linear equations, if time permits. We will see how you can see, right? And when you just start practicing, when you practice more and more, you will get to learn it. So let's say today what you do is take your 12th standard or anything online. You can take that linear algebra book and start doing the determinant inverse of the matrix with the MATLAB and verify with that book. Okay. So it is used, MATLAB is used in modeling and simulation, signal processing, image processing, processing big data. Okay. So let me show you one more thing. Is left is the live script. Okay, then we will move to the question answer session. This is the script. Okay, this is the normal script that we have seen. Let me clear all this. CLC clear. Done. So let's close the script. This is my live script linear equation that I already made. Quadratic equation. So live script is the advanced version of the script. Okay. So here, what you can do is you can use that interactive LaTeX style here with MATLAB, because you see we have written x square like this, but in book it was written like this. Why? It is with the use of the LaTeX you can do that. So here live script, here it is the text, right? You can write anything describing the function. Here it is the code that you are running, right? Let's say I am calculating the quadratic equation. So I want to explain first what is my quadratic equation. I have written here, then I have written the input, then how to find roots. So this is the formula for roots, and how to write it in a code. So we are writing this like this. Let us write it again so that you can understand it well. Okay, I'm writing, let's say I've defined the variable ABC and I want to find the roots. Formula is here. So what I will do is I will do one bracket here, I will take a lot of space, but space is not required. You can, but try to apply a lot of space so that you can understand it afterwards. I can do minus B, and then I was doing plus, and then I was doing one more bracket for power 0.5. Okay, here it is b square b power 2 minus, I will not write 4ac because MATLAB don't know what is 4ac. You need to write multiply sign in between a multiplied by c. Okay, so my numerator is completed. Understand? Try to understand it. Minus 1 plus b square minus 4a, it was written wrong, 4ac, and root this bracket plus this divided by 2a, but don't write 2a. Write 2 multiplied by a. Okay, then you need to save it, and when I run, also here it is the benefit that you can only run this much section, or you can run the whole program. If you click here, it will run the only that section only. So this is how you can use the live script. Here you can explain your code and then write your code. Explain your code, write your code, and you can use the LaTeX environment to writing things like this. Okay, so in your thesis work or some report generation, this is very useful. You can use this way, or also there are another way, publishing it to PDF or HTML are available, but this is also the one of the way to showcase your work, right? So I think it's almost over. Okay, so let us first, if you have any doubts regarding this live script, let us ask, so ask that first, and then we will move to the general questions. Okay, so first, how to write those text in live script. Okay, so let me take an example of one live script. I will, let me close all these things. I will open, previously we have used a new script. That is, if you click here, it will open the new script. If I clicked here, you will got a new live script. Okay, as I have clicked here, you see this is by default, it opens the coding window, but I don't want, let's say I want the text. So I will click a text. So it will convert a text, write anything. Okay, write anything here. Let's say now I have explained what my code is. Now I want to write code. Then I will simply click code. My code is, let's say, is equal to 2. My code is over. I want one more text. Then I will click text. Okay, this will return to text. Then code. This is code. So, and you can save this and you can run only this section, this section. Okay. Yeah, I will coming back to that page. Yes, you can edit the LaTeX part of that script. Let me show you. Yeah, in script you can edit everything. That's why the script are usable. You see, LaTeX part is written like this. Okay, this is how LaTeX is written. You want to see this? How this is written? This is how it is written. This is written in the LaTeX scale, right? You want to see this? This is how it is written. Okay, and when I put the $sign here, this will look like this. So don't worry about this LaTeX thing right now. Just focus on learning in MATLAB. Okay. So, right, you can ask any question you want. I'm going to that page. Okay. So here our matrix is of 2 dimension. Let's say this is 1 dimension. This is the another dimension, right? This is known as rows, horizontal ones, and vertical ones are known as column, right? We know this already. Okay. Now, let's say you are writing this thing on first page of your book, first page. Okay, then you are making another 3 by 2 matrix on the second page. You are writing another 3 by 2 matrix on third page, and let's say you have written similar things in 3 page. So it will be look like your 3D matrix. Do you understand? There is a matrix, there is one matrix, below another matrix, and below another matrix. So that is page I am talking about. It there is no such thing like page. This is just for understanding. Okay. So there are that is how 3-dimensional matrix are produced. Okay. So any other doubts? 3 by 2 by 3 matrix. Okay, 3 by 2. Let's say first is the row, right? There are 3 rows here, 3 rows, 2 columns, that is 2 columns, and 3 that defines the number of page. Okay, number of page. You have 3 by 2 matrix on 3 page. If you have 4 page, then 3 by 2 by 4. Okay. If want gap such that it changes between Roshan Kumar, I don't get it. Okay. How to run particular section of that code? Okay, where you are in this section, let's say I want to run only this section. So what you just need to click here, run section. It will run that particular section. Okay. If you want gap such that it changes between numbers, then how? Roshan, it's not possible. There are only currently two commands that using column and Linspace. And if you want to automate such thing, then you can use the loops and do that things. Okay, so when you learn loop and function, then you can do that whatever you want. Where are the 3D matrices used? Okay, I don't remember any particular application right now. Maybe look in numerical methods, and when you are dealing with big data or image processing, you are dealing with matrix, very bigger matrix, like 100 by 100 matrix, 1000 by 1000 matrix. Okay, in that scenario, you can divide that, or maybe you can concate that matrix. In that scenario, this all will be very much useful. Software is MATLAB. Which software? Can we export live spread as PDF or? Yes, there is a. Let me. Okay, let me show you the exporting thing. Okay, so here, when you save this file, you can save this at as it is MATLAB file. You can export to PDF. You can export to Word, HTML, LaTeX, or folder, whatever you want. You can click on that. It will give you. Let's say, let me click back export to PDF. Okay, here quadratic equation is my open, and I'm clicking export to PDF. Okay, save, and see the PDF will be generated. Right. So you can see a very nice PDF is generated of our code. Okay, so here you can, in the save option, there are lots of exporting option available. You can also download on a local machine. Okay, format loose. Let me explain loose format with the script. So when I run this script, see, there are a lot of space. If I compact, it will become compact, right? And when I write the format loose, then it will add some more space between. That's it. Format loose and format that. Okay. You will learn all these things, how you can import data in further sessions. Just wait, this is just the starting. Okay, so please check if there are any other question in the live where we can practice problem basing and hacker at support. So you can just Raju Singh, you can just Google it. You will find a lot of material. Okay, but just attend all the session. You will get to learn all the things and practice whatever is taught. Okay, so
Here we have a question on YouTube Live. Can we add comments in the command window?
Yeah, why not? But that's of not much use. Like this is my comment, right? Yeah, it will do nothing. The comment is a thing that will do nothing. This is just for the user purpose, not for computer, just for our understanding, right? So you can write a comment just to understand the code, and if you share the code, someone else can understanding the code. That's it, nothing else. Okay. So I think there are no questions.
Do anyone have questions? You can raise your hand or you can speak directly.
Any of the audience, I mean, they can directly unmute themselves and just ask.
Sir, I have a doubt.
Yes.
Can I ask?
Yes. Go on.
Sir, actually I joined late, so I want to know that what is the use of MATLAB? Is it related to coding somewhat?
Yeah, look, MATLAB is itself a coding language. It is used in many fields, as I have discussed here. Right? Look here. You can have some assignments. Professor will give you some assignments in the MATLAB there, and it is MATLAB in simple words. Let me tell you, MATLAB is just a fancy calculator. Okay, but it's so fancy. You can do a lot of simultaneous calculation, big calculations in it. These are the applications of the MATLAB, right?
Okay.
Whatever you are solving on your pen and paper, you can do more than that in the MATLAB. Okay.
Sir, can we get the recording for this session or is it not available?
You will get that in YouTube.
Okay.
Yes, Anil.
Yes,
Before ending
yes,
the
sir.
meeting,
Yeah,
so before ending the meeting, please stop YouTube live.
okay.
Hello, sir.
Yes.
Sir, this PDF will be shared with us.
Okay, I will share it tomorrow. Okay.
Oh, okay, sir. Thank you.
In tomorrow's session. So let's end this session. Thank you.
Thank you, sir.
Thank you very much. See you.
Yeah, you're welcome.